I want to get to introducing our opening keynote speaker. I want to say just a few words about him. A lot of you know that Bjarne is the guy that created C++, but what a lot of people don't know is that he is very, very interested in education. When he left his position as a corporate researcher to become an academic researcher, he also took on the responsibility of educating undergraduate engineers in how to program. Not in how to program in C++, but how to program using C++. And he took those insights and those lessons learned and turned them into a very, very successful textbook, again, on how to program using C++, but how to program. And so I think that when we think about our role as engineers on a day-to-day basis, we spend some of our time as students and some of our time as teachers. And if we're going to be successful engineers, we're going to be successful as students and successful as teachers. And so I'm very interested and very excited to hear what Bjarne has to say. I did say, however, that I have a special announcement for you today, and I want to put that in. I forgot to cover that. We'll be announcing a lot of winners. We'll announce the SCM Challenge winners. We're going to announce the Microsoft Drawing winner and the poster competition winners. There's another winner I'm going to announce right now. This is announced today. It's not us. It's the Institute of Engineering and Technology. This is the oldest professional engineering society in the UK, possibly in the entire world. And they've announced today their Faraday Award winner. The Faraday Award is the most prestigious award that they give from the oldest professional engineering society. Previous winners have included Maurice Wilkes, Tony Hoare, Roger Needham, Donald Knuth. Today they've announced the 2017 winner was Bjarne Stroustrup. So we thought we'd ask him to come up and say a few words.
Thanks. I'm very honored about that award and very pleased. If you read the list of people who had gotten that award, mostly they're not computer scientists. You'll see it's downright intimidating. Let's see. Am I pumping bits here? Yes. So when I was asked to give this opening keynote, which I've done before, so I had a problem, which is, what can I talk about that is important to most of us, and that I know something about, and that we haven't heard a million times at this conference. Most of the time, we do what we always do. We do the reasonable, rational thing. We don't fight any fights that can be avoided because we're busy. This is the way the world gets stuck and no progress happens. So I picked this quote from George Bernard Shaw about how you have to do unreasonable things sometimes. And that's what lies behind a lot of what I'm going to say here. I mean, what should we do? What's not right? And what can we do to fix it? This is, in my opinion, an intensely practical talk. And basically, I'm going to talk a little bit about teaching programming. And then I'm going to go into something slightly more technical, not teaching technical, not how you organize a classroom or whether what particular tools you use to grade your students or find cheaters or things like that. None of that. That's not what I'm talking about. This is not really an education forum. This is a forum of professionals, people who develop stuff, with a few teachers sprinkled around. So, and then I'm going to go into some details about what we teach as opposed to how we do it. And we're all teachers. And we have some fundamental questions, which is what do we teach and why? Well, what is it we want to achieve? And who do we teach and how? Those are key questions. And we're all students. The world is moving on. It's moving very, very fast. It's moving too fast for any of us to keep up on everything. And so we have to be students, basically all the time, at least a little bit of the time all the time. Otherwise, we fall behind, and then we become part of the problem. And it's a huge problem. If you've ever had a piece of 20-year-old code dumped on you and had to look at this horrible mess of, say, overgrown, illogical class hierarchies littered with with memory leaks and pointer spaghetti and such, you can usually thank some teacher somewhere. They don't get it right all the time. And if you've ever gotten people in from a good university course and they couldn't program their way out of a paper bag, again, that's part of the problem. And so I'm going to try and do a little bit of rabble-rousing over we have to do better. Not because I'm criticizing anybody in particular, but I feel not only do we have to do better, we can. We're not all professors, as I said, and teaching occurs all the time. We have a colleague dropping in, talking about it, or we give a little local course about the latest features and such. Basically, we give advice. That's teaching. We better give good advice. We better give useful advice. We better give advice that brings the world forward a bit instead of stifling yet another innocent novice. And one of the things that bothers me a lot is that sometimes people have the weirdest idea of what C++ is. I'll get back to that. But basically, when you're giving advice, when you're giving a short presentation, when you're giving a course, think about what it is you want to achieve and work backwards from that. Don't start with what have we always done and what is easy to get started, or if you're a professor, what's easy to set tests for. I mean, anything that can be tested by a multiple choice test is usually bad. All the interesting stuff is the stuff that is sort of more real, harder to quantify specifically. And so who do we teach? Depends who we are, of course. There's students, in which case you have some chance of knowing their background, though I've taught freshmen, and they come in from high schools, and they're all over the place. When I started teaching freshmen, it was 60% electrical engineers, and the rest was computer engineers. Computer science was being advanced and doing Java, and I got the electrical engineers. 2 years later, when my electrical engineers significantly outprogrammed the computer scientists, the computer science department changed. But basically, you have to look at the students, the people you talk to, the people you change, and try and understand them. What's their background? What is it they know? What is it they don't know? And what is it that will do good for them in the future? And of course, what do they want, which may not be the same. Industrial programmers, again, the same thing. Background, aims for the future. And there's a lot of professional non-programmers that are using C++. People who are physicists, biologists, historians, they have a totally different view of what is important. A lot of them go for the thing that's easiest to pick up, which these days usually is Python. And then they run out of CPU power. I heard about a biologist that was running 3-month runs to get his data. it could be done in just over 10 minutes. We know that because that was done when he couldn't do it in 3 months anymore. We have to help those. There are so many in the world, and they're doing so many important, interesting things. They deserve our help. And basically, the most fundamental thing about teaching, I think, is that the students are, by and large, not like you. On average, they are not like you, and on average, we assume they are just like us. Hey, we've all been to school, so we know what it is to learn, right? We just do what we did 20 years ago in kindergarten? No. You have to think a little bit harder about these things, and you have to learn. Learn about the students, learn about their needs. And I think we did a really lousy job teaching C++ before the first standard, and not much better later. We there definitely include me. Basically, the message about what C++ was hijacked by everybody that wanted to hijack something. C++ wasn't supposed to succeed those days. There's always fashions, and they will determine what people think is right. A lot of C++ got hijacked by people who thought it was C with a few knobs on the side, and others got hijacked by people with the rah, everything is a member function, virtual member function preferably, and everything should be dynamic somehow. We have gotten a lot of really bad code out of that kind of stuff. And it's partly because me and others did not articulate clearly enough what C++ was and how it could be used well. And this got amplified through textbooks, through conferences and things like that. We just have to do better. People talk about getting the message out, messaging and all of that kind of stuff. I used to think it was rubbish. No, it's right. You have to phrase the message, you have to repeat it, and you have to get it right, and then you have to get it out there. So I want to teach good modern C++, which leaves us with a little problem of defining modern. But I'll get to that. So I have a background in this. I hate talking about things that I don't know anything about, and by and large, don't know anything about I define as having not done it for real. One of the problems with education, by the way, is that the previous occupation of most professors was student. And that's, I don't think, is just the right background for teaching people how to do good stuff in, say, industry. Fortunately, this is, again, it's not universal. When I'm criticizing something with a broad brush, it's not because I think everybody has that problem. It's because I have to be brief, and if I put all the caveats and exceptions in, it gets a little bit woolly, but a lot of people have that problem, a lot of people don't. So I still teach. I give a course every spring at Columbia, and I talk to a lot of people, give talks, interact on specific projects. So I do have some experience in this. And I've written a couple of books that are in wide use. I think one thing you should note there is that they are different. They aim at different things. The Swan book is aimed at people just learning to program. The Tour book is meant for people who may have fallen 5, 10, 15 years behind with C++ and needs a refresher and are so busy that they only have a weekend to do it. That's the design criteria for that one. And the thick book is, well, for people who need to know everything in quite some detail. And, well, the standard is not a tutorial. So basically, when you teach, figure out what is it you want to achieve, work backwards from that, and write it or say it or something like that. So once I decided to give this talk, and promised to give it, and still having no idea what I was going to say, I asked a few people, and I got some responses. The thing that first surprised me was the industrial response. It was uniformly, great, we want better developers. Give them hell, this is good. Now, the teachers were different. Yeah, that's great. It really, really needs attention. But you know, it's hard. I mean, we failed so often. And what can you say that's in any way new or interesting? And I'm not sure. I'm trying. If nothing else, you're not the standard educators or audience. So maybe some of the things I say are new and more helpful than they would be if you were worn down 20 years veterans of the education system. And me, I think it's very important, but it's practical. It is not education theory or language theory. It is something that happens, whether we want it or not, every day. In classrooms, in labs, in sort of development floors, and we have to do it. And we need to balance two things: principles, ideals, things that we would like to see done right. Remember George Bernard Shaw? And then the practical skills that it takes to make a positive change. You can't just go and talk about it. It has to actually work, and you have to build it. So that gets back to what we're doing. What do we teach? There are many, many ways of using C++. I mean, there's people going around saying things like, C++ programmers do this, or this is the way C++ is written. And they're usually so darn certain. I'm not. I have seen enough C++, I've seen enough C++ programmers to know that generalizing over the whole group and then simplifying it to this is the one true right thing is just ridiculous. Nobody knows enough, nobody can be precise enough, nobody can give brief advice that is wide enough to actually help everybody. So we must choose. We cannot just teach everything. There's too much. And anyway, we don't know everything. And so one of the things that I recommend anybody who is in a position where they do teaching, advising, mentoring, or such, is to think a little bit about what are your aims and try and write them down. I find writing things down is really, really helpful. It's one of the things that makes us honest. And especially if you show it to some of your friends and victims or whatever, you can get something that is better than what you first thought out. And you have to remember that the students will choose what's important. They will tune out a lot of what you say. They will listen to people who says exactly the opposite, and they may believe them and they may not believe them. That depends how well you're doing the job and how convincing people on say Reddit is. And so you must choose because, well, everybody does. And so here there are lots of aims, very reasonable aims for what you teach, and from there comes some of it, how you teach it. There are a lot of people talking about, let's get people really excited about coding. That's very important, especially for the young ones, but it's not my main focus. Somebody else is better at it than I am. Not that I don't sometimes go and talk to high school students and middle school students where that's my job, but when I talk, it's not what I'm thinking about most of the time. I'm thinking about how do we lay a foundation for careers in system development, whatever you want to call it, and also how do you talk to people who are not actually going to be full-time developers, full-time computer scientists, but is going to use a lot of that. Those are my two main focuses. There are people who says, well, let's get them to write a simple program, and that's their aim. That's their whole aim. I think that very often leads them to teach things that convinces the best and the brightest that computer science is boring, that system development is boring because they can do simple things easy. And then that's it. I worry about that. And then, of course, there are people who just want to enroll more people so that they can get more funding for the teaching. And that very often leads to bad teaching and to spoon feeding. Okay, so have problems with C++ textbooks. They very often don't focus. And if they do, they don't say what the focus is supposed to be, so it's hard for teachers and teaching assistants to actually know where to direct things. And very often they're slow, bottom-up, focus on what can be tested, and teaching 1990s C++ with C++11 syntax. If you find a book like that, I am not going to mention any, but you will know them, that's not right. So basically we have to teach programming. It's not just language features, it's programming techniques, and it's not just what is valid. I mean, a tester like, how weird examples can you come up with for the conversion of an unsigned short to an signed int is basically uninteresting. That is not what the thing is about. That's debugging and reading the manual. You can do that once you program, but you have to give some advice about how to write code so that you don't get that question. If you write good code, if you have that question, you probably are doing something wrong. And we can't try and teach everything, at least not at once. We start from the beginning. There's far too much stuff we have to choose. And we need great libraries. I think one of the things that's wrong with a lot of early C++ teaching is that they teach the language in isolation. You get to page 697 and you get vector. And sort is mentioned 100 pages later. That teaches students that the standard library is boring, uninteresting, advanced, difficult stuff. Whereas it teaches them that if you write your own linked list, you're cool. If you write your own hash table, it must be better than that standard stuff. This is wrong. Wrong, 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 wrong. Exactly. So we need great libraries. There's nothing much to do with C++ there, but that's a great library. That's the Trinity Library in Cambridge. So another thing is, when you teach, try not to be too clever. People always want to know the latest. And we love to tell people the latest. The problem is that most people who ask for this and haven't actually learned the foundational stuff. So you have to sort of pull back. Teach people how to do basic things, teach people how to do simple things. When you're illustrating a technique, don't use the most advanced algorithm you can find. I wouldn't pick bubble sort, but I wouldn't go to the full generality of everything in the first class. And simplify things. The best example is the simplest example that illustrates a technique or a feature or something like that. Simplification is a really important thing in teaching. And always give a rationale. Don't just tell people, do this, it's good for you, it builds character. And you might get an A if you answer it just right. Those are very short-term, silly arguments, and we need to do better than that. You have to say why people should follow the rules, the suggestions you're making. And the purpose of good teaching is to get ideas into people's heads. Sometimes you forget that. Teachers forget that. They focus on grading, they focus on techniques, they focus on the detailed subject matter, and they forget that it's not just to show them something. You actually they have to understand it. You have to explain what it is, why it is, and what it's good for, not just one of the things. And don't show off. I mean, it is so tempting to show off to a colleague, to stand in front of a group of people and show them something. Look, this is clever. You don't get it, right? That means I'm smart. That is not good teaching. It is really, when you do it right, people will come out and says, yeah, what's that? Oh, simple. Yeah. You've gotten it into their heads. Brian Kernighan once told me, you know, if they notice you slipped the knife in, you haven't done it right. He's a superb teacher. I wish there was something like egoless teaching, but I don't think there is. But we have to keep our egos in control, remembering that the purpose of the exercise is to teach somebody else something useful. I mean, yeah, we learn something when we're teaching, but that's not the main point. By the way, that's William Ockham, he of the Great Razor. Very good for use in teaching. So basically, we have to use tools. We tend to focus on just the compiler and a few sort of statements and a very limited number of libraries, especially in early teaching. And then people are thrown into the real world where they drown in complicated tools and libraries. I do not know how to do this. There are so many things and so little time. But eventually people will learn about all of these things, and it's a good idea if the people at least knew what they didn't know and had some idea that someday when your program is more than 1,000 lines long, you may actually need some of these supports. And not just to make it easy to do simple things, but something that scales to larger things. And again, principles and practice, you can't just lecture about programming. It's a practical skill. I mean, I sometimes say, you think you can learn bicycling from a correspondence course? Do you think you can learn design without designing things, programming without writing code, programming without reading somebody else's code? People do believe those things, and that's wrong. On the other hand, you shouldn't just hack. There's a lot of people that learn from just looking at what other people are doing and what other people are saying, and they just throw code together. Cut and paste is the ultimate of that. Don't just hack. You have to have the principles also, but you have to have hands-on thing. And it's not easy, it's not quick, nobody can do anything, but do something. I mean, throw in a robot or get people to use a Raspberry Pi or something. This is probably obvious here. It is not obvious to a lot of universities at the first couple of years. And complexity is the enemy of just about everything, including good teaching. Try and keep it simple, focus on simplicity, and don't throw all of C++ at people. They won't be able to understand it anyway. Basically, we tend to focus the students on a few things, and a lot of courses doesn't have graphics, GUI, web, email, database kind of libraries. That's some other course, which most of them never take. And they come out believing, almost because they've almost been told it, that there is no graphics, no GUI, no web, no email, etc. The fact that the whole world is run by C++ using those features is completely missed in the classroom. When I was teaching, I tended to use the first 5 minutes of every lecture to talk about some application. So what does the software on the Mars rovers look like? How do you think Google works? And things like that. Good stuff, motivate people. Personally, the thing that keeps me going is the applications. And so, don't think there is one way. I really fear monocultures, single language, single operating system, single curriculum, when everybody copies from each other and gets the same things from the web. There should be many ways. The argument that's not the way other people do it, if they do it at Harvard, it must be right, is not conclusive arguments. You look at what others are doing, you try and learn from it, but is there an angle of your own that you can use? Are your university next to a tractor factory? Maybe programming tractors would be a good idea. My hometown was into wind turbines, and so there's an example there. Something that can inspire people. And don't hype. I was criticized a lot in the early years for pointing out that, in my opinion, C++ could double your productivity. Everybody else promised orders of magnitudes, transformative change. How do you get a transformative change? Little step at a time. I don't believe you have this great genius that just solves all your problems like that. That's not engineering. It may be certain branches of math, but it is not when you have to actually build a large, complicated system, have all the pieces work together. So don't hype. And don't let people believe in magic. I mean, friends don't let friends believe in magic or something like that. I really try to explain people how it works. So you explain the library, then you explain the techniques that the library is using, then you explain a little bit about how it interacts with the hardware, and if you are really on a roll, you can just tell them a little bit about how the hardware works. I mean, it's abstractions all the way down, and people should understand this. I meet too many people who do one level of the system and then aren't interested in how it is really done. I mean, I'm frustrated if I don't understand what the next level down the abstraction stack is. I can't know everything, but at least I feel bad about it. If you feel proud that you don't understand hardware, there's something fundamentally wrong. If you feel proud that you don't know how your library is interacting with the operating system and how often, one, you shouldn't be proud of it. Two, you will not write low latency software or high reliability software. This is practical. And basically we have to succeed. The main argument is that we will depend in our daily lives on the code written by the next generation of programmers. So if we screw up, we'll pay for it. Some way or other. So we should focus on this. And a certain amount of idealism is necessary. If people just have the attitude, I do my job in the simplest way, let's not rock the boat. A lot of people do that. For some people, that's the only strategy that makes any sense. However, some of us has to rock the boat. And we have to make some change. That requires idealism. It requires you thinking about what you want to do, what would be good, what change is necessary, and sometimes a lot of work on it. I have an ideal along the lines of, you know, doctors have certain professionalism. There's things they just don't do. And if they do, they get into real trouble. Same with engineers. We build things that are at least as essential for our world as the hardware engineers and the medical doctors. After all, what tools do they use? And we should hold ourselves to a very high standard there. So we have to do it better, and we have to start out right and then keep doing the right thing. Yeah, Lego is programmed in C++. So let's try first a little bit by analogy. How does other fields deal with the problem of getting people on board and appropriate levels of complexity for them? And I like cameras and photography, so I'm going to do an analogy with photography. Remember, proof by analogy is fraud, so this is just an illustration, nothing more. You can't just copy it. But basically, there are very great similarities. The results depends on the equipment we're using. It depends on the user. It's not an automated process that just runs. That means you need teaching, training, experience, and such. And there's lots and lots of components involved in both software and in photography. And users differ dramatically. I mean, my main weakness in photography is that I never have the time to take the to take the necessary effort to learn my equipment and to spend the hours necessary for the light to be just right. I mean, you can't just pull the sun up and down as needed. You have patience. That's my weakness. I have it. That's what people have different skills. People have different cost factors. Individual needs, taste, and skills change over time. This is true for both photography and programming. This is why I think the analogy might be enlightening. And needs differ. And a system there's lots of parts to it. If you're programming in a programming environment, your libraries, language features and such is one system, and you can't just start using something totally different. Similarly with photography. So basically, there's a professional level camera. It weighs a ton. That disqualifies it for me, by the way. I like to travel light. It takes superb photographs if you know what you're doing and if you take your time. I don't have that time. I don't have that patience. Furthermore, you can completely drown in equipment. Boy, I mean, if you're a gearhead, there's no end to the number of gadgets you can attach to your system. And similarly, there are people who never saw a library or a language feature that they didn't want to use in their latest project. Now, there are things that are geared for people with less skills and less patience. A lot of work has gone in to designing these things so that mistakes aren't really disastrous. I mean, a slightly blurred picture is still a picture, and a slightly off program is a good start. And they tend to be self-contained. That is, you get a package, you use it. And we're not good at that in programming. I mean, people get the C++ compiler, and then where's the GUI? Where's the standard, where's the graphics library? The greatest problem when I was teaching undergrads was to get the GUI library installed. This is where the real world hits. It's painful, and it doesn't integrate well. And my students were using Macs and Linux boxes and Windows boxes, and it's all different. Same library, all the code is portable, but just getting it installed is painful. These packages are done to basically have everything in the box, and it works right out of the box. And I think I would like to see that. But there's another aspect of these things, is that the various manufacturers, Sony, those were Canons, or some Olympuses, some Nikons there, each has a system where you can learn and then upgrade to the next level. Not totally painless, but less painless. The user interfaces are sort of standard. I can pick up any camera and do a simple point and shoot kind of thing. It's standardized across there. And each has a way that makes it easier to go up if you need more, or to go down if you are not in the professional mood. I mean, I make better pictures in the first 2 days if I use a point and shoot. But if I have a vacation, I can the first 2 days I will screw up with the more advanced equipment, but then I'll get better. You can move up and down these levels. So I think we need a system. One system does not fit all. If we give the professional camera to an amateur, one, they won't be interested. Two, they will make really bad results. And we need some kind of idea about interchangeable parts and things like that. And there should be distributions. I should say, give me the amateur version. And I should basically not have to say much more than I just did there. Give me the enthusiast version. I come something with 10 times the number of knobs and dials. And if you are a professional, you ask for the professional. It's going to be more painful, but you're going to beat all the amateurs if you know what you're doing. And so why 3? Why can't we just say, here's the perfect system? Because there's no perfect person. There's no one person that needs all of that kind of stuff. We have a tendency of throwing everything at it. Look at teaching, look at what you get out of the box with a standard. You get everything that you need to write the kernel of an operating system, more or less. And 99.99% of people don't ever see that and shouldn't see it because they're doing something else. So basically, we are doing something. We are doing something. We are moving in the right direction. Modules will help. This is the way I would like my code to look like. Give me the entry-level bundle. That's all that needed. And if I want the enthusiast level bundle, I want that instead. So I have the choice, and it's a hard granularity. It's a coarse granularity. Maybe I want to say, give me the basic games package or something like that. But we have to limit the number of things that people can get so that they can not get lost in the details. And then you can add things that's not part of the foundation, 2D graphics, 3D graphics, da-da-da-da-da-da. Okay, and we need a better package and build system. There are package systems out there. They're improving, thanks to all of you that's working on that. But the average student, the average user, get lost in how do you download something, how do you install something, how do you know it works with the stuff I get from over there plus the stuff I'm getting from over there. We need to do better. I really want my operating system to say, give me the GUI from XYZ, install it, and then I should be able to import it. If it's more complicated than that, it's probably too complicated. This is not just for the novices, it's not just for the first-year students, it's for all of us when we're entering a new field that we're not experts in. I have this distinct feeling that in most fields I'm not an expert. In most fields I do things I'm not an expert, because I'm learning new things and I'm getting into new things, and so I'm an amateur and I need all the help I can get. So let's go to slightly more philosophical thing and then to some code. There's no value neutral teaching. When we teach, we say what's important. And explicitly or implicitly, we condemn something as bad. We decide what we would like the students to learn, and if we teach well, they'll believe us. If we teach badly, they won't. But we have to decide what it is we want people to get. In particular, if we're teaching C++ at some level, what is it? What's good about it? Where do we want to go? What would you like your code to look like in 5 years or tomorrow? Do we want to write 1980s C++? Some people do, but I don't think they should. So my primary interest again is get a professional attitude, dependability, maintainability. Performance is important in most of what I'm doing. It's not everybody's essential thing, but it's important in C++, and reasonable cost. These are sort of engineering concerns, not science concerns as such. And so here's my summary of C++ as ever. I like static type safety, precisely specified interfaces. I need resource safety. People have to understand constructors, destructors, RAII. What is the value of abstraction? How do you use it? How do you do generic programming and use templates well, as opposed to just use templates? And simplicity for most developers. This, I think, is key. I did a small survey of textbooks about C++ while writing this, and it's a sorry result. Mitch, do you know a textbook that emphasizes these things? I think a lot of them don't even mention it. It's outside the scope, and that's pretty bad. And change is hard. Modern C++ is not sort of in particular. It's the most effective way of using C++ today, given the current standard, which is now C++ 17. It was formally approved a few days ago. And inertia is the enemy of good code. I mean, professors, yeah, it's not the way we do it. It doesn't fit into the curriculum. Maybe we can make a change in 5 years when the data structure course is willing to do a more modern thing. And students, they reject what they didn't expect, and they expect from the strangest places, often the web, often their friends. And a lot of students, I find, are convinced they are smarter than their professors. And, you know, sometimes they're right. Especially a lot of high school teachers have been smarter than their high school teachers, especially in computing, where computing has not been a key thing, where we don't have a good solid curriculum like they've got in calculus. Quite often the teachers are not as smart as the smartest students, so if you get the smartest students into a university course or into a job, they may have a slightly jaded opinion about their teachers. That will apply to you too, because you are now in the role of the teacher. And I have definitely had people repeatedly every year in the course, freshmen coming out of Texas high schools, who are absolutely convinced they're smarter than I am on the topic of programming. In this particular case, I'm reasonably sure they're wrong, but it is something that has to be taken into account and dealt with. They don't take it just because you say it. And we have to worry about current practice, because it's very often what was fashionable 10, 20, or 30 years ago. By the way, this year Simula is 50 years old, so object-oriented programming is now 50 years old. For somebody who thinks it was cool and modern, just remember 50 years. We're that far into it. So, modern C++, I define it as the best practices using the current standard, possibly with TSs. And basically, I aim for completely type-safe and completely resource-safe code. And there's a project which I launched here 2 years ago about the C++ core guidelines that basically tries to codify this as a set of rules. This is not what C++ is. It's a kind of way of saying what are the good practices, how do you get started into this. I mean, it's not something that's enforced by the compiler or everybody has to do just like that, but you really need a good reason to do something different, is the way I define it. It's a very active project. There are dozens of contributors every month, and it's a very wide sort of set of contributors. I mean, where else do you find Microsoft and Red Hat doing something together regularly? The world is improving. Code examples. Programming has to do with code in the end, so good examples are key. I sweat blood trying to find good examples, and I'm never as successful as I would like to be, because they have to be simple. For teaching to a class, it has to fit on a slide or a couple of slides. If people show me this much code, the ideas are going to be lost in the code. You can't get the idea there. Yeah, if you're in a work environment and you can sit over a screen with a guy that walks you through it, great. But in many, many cases, finding simple examples is really, really hard. And also the big examples, sometimes aren't the greatest examples. They have all the warts that was necessary for compatibility, for the way we usually do here and the conventions that have grown up since the 90s. So finding small examples are key. And don't separate code from explanation. If you just show the code, people will not get the idea and they will invent reasons why it looks like that. And those reasons are sometimes seriously weird. If you give them just the explanation, that's sort of the standard lecture of what is good and proper, and people go to sleep. They don't get the idea. So a tight integration between examples and explanation is essential. I learned that from Brian Kernighan. If you haven't, read the introduction, the tutorial, the first chapter of K&R again. It's a beautiful example of how you can get ideas into people's heads. C would have been among the dozens of failed attempts to do what C did if it wasn't for that book and that style of teaching. It's very important. Brian is, by the way, a really nice guy. The fights between the C community and the C++ community did not happen between me and Brian and Dennis. That's fact. So let's look. I can't give a talk without code. So I'm going to show you a few examples of what I think. So here are two ways of writing a loop. The first is the good old way, which we have written more or less that way since the early 80s. And then there is a new fancy way with the range 4. And y is 2 better than 1. Basically 2 states what I want to do for all x in V. There's no I didn't need an I. There's no separation between finding the limit of my data structure and the use of that variable, constant, whatever you want to call it. So I can't make a mistake about getting the size wrong. And you can explain this. This is easy. So it's shorter, less opportunities for mistakes. And you know, yeah, one is more general. You can express more cases. But that also means you can make more mistakes. So remember, goto is the simplest and most general structure, the control structure, at least non-concurrent. But you can implement concurrency with a goto anyway. So basically, just because you can do more doesn't mean it's better. Sometimes it means it's worse. The fact that goto can do everything is the fundamental reason why we don't use it, except in machine-generated code and such. Yes. Here's some example, slightly more modern example. I am going to blink some LEDs. And there are 2 ways of doing it. I can give an integer and it blinks. And I can give a millisecond argument that says how many milliseconds they can blink. Now, if you use integers, you have to guess about the unit. And so if you have blink number 2 and you just give it something without a unit, the compiler says, well, you didn't tell me what the unit was, I won't compile this for you. This is good. And the reason it's good, my best example is that little spaceship there, the poor little Mars climate orbiter. It was sent up to Mars, and it was doing the final course corrections to get around Mars in a good orbit, and it disappeared. My favorite theory at the time was that it's been kidnapped for ransom by the Martians. There's also people that claim it was a Yankee go home thing. No, you don't want any stinking earthlings here. However, what happened was more relevant and less interesting. There were 2 groups of engineers, and they were transmitting a power reading through an interface that took a double. On the one hand, they had SI system, MKS. On the other side, they had the imperial system. As that double passed through the interface, it changed its meaning with a factor of exactly 4.65. and we never saw that little spaceship again. That means that about the lifetime's work of 200 good engineers just disappeared. Basically, it all worked for nothing. They got the salary, but it didn't deliver anything of value to the world. All the scientists that was waiting for the data had to wait. Lots of promotions didn't happen. Lots of students didn't get their degrees. And basically we lost about $600 million, and it took 15 years more to get one up. That was the bug that you see there in the first use of Blink LED 1500. Some bugs can be really critical, and we can do better than that. And if you want to be generic, you can do that too. Modern C++ is very flexible, and you can use that flexibility to gain precision. So here we have some of the rules from the core guidelines. Make interfaces precisely and strongly typed. That's an example of that. And we can go further. Always initialize an object. This is a thing that people break again and again and again. They are so smart. They know they are going to initialize it, but they declare it up here and then they initialize it down here, and they get it right all the time because they're good, clever programmers. No. Even if they get it right, somebody else is going to write code in there, or you have handled all three possible cases and somebody invents a fourth case. So one of the rules is always initialize an object. And that always have some pressure because people have had other ways of doing things over the years. Like, I like to define all of my variables up top in the program, and then I initialize them the way I always did in Pascal and other languages further down. After all, I would like to see where all of my variables are. That, by the way, is a sign that your function is too large, which is another rule. But here, always initialize the object. Now, sometimes you can't do that. So you have to deal with exceptions like input buffers. And in particular, multiple out values have been a problem over the years because, well, if you have to call a function to calculate the initial value of 2 or more variables, then you end up having some things like that error code there. You call the channel, you pass the error code in uninitialized as a out parameter, and you don't say so, the reader can guess it. No, and then you have to chase it. So in C++ 17 we have structured bindings where we can say I want to break the result of the channel open into its component parts. And so we can now return n values and use them as individual variables instead of having them into an object and accessing the object in certain ways. So always initialize objects and return multiple out values as opposed to using out parameters, which is a known bug source. One of the ways when we are developing this is to look at bug logs. What do people get wrong? What can we do to fix it? Again, we're not trying to be clever here. We're actually trying to find out the least clever ways that work. Basically, develop an error handling strategy early in the design. That's a rule. It's sort of philosophical. You can't have a static analyzer find it when you haven't. Some rules are high level, some rules are low level and checkable. Throw an exception to signal it. Exceptions are for error handling only. So if you look here, I've gotten too far down here. Yeah, I showed you. No, I did not show you this. So first, we start out with the classical style without parameters. Then we use structured bindings. And finally, we can start discussing, should it have returned 2 values? Should it have thrown an exception? And this is where one of the tricky bits is to say, when do you throw an exception, when do you have an error code? Is it normal to fail? Is it expected to fail? Then it's probably an error code. If it's considered a design failure or an extremely rare event that it fails, it should be an exception, is the answer in the core guidelines. And basically, don't be too clever. In the context of using C++, clever is a swear word. Don't be clever. So here is some code, slightly simplified. It's got a really bad bug in it. I don't know how many of you spotted it. How many of you would have spotted it if it had been in code that was a couple of screenfuls? It is trivial for a static analyzer to catch this. The problem is that people are messing with resource management, and there are some rules. Don't leak resources. Don't call new and delete explicitly in application code. It should be encapsulated into a resource manager. And a raw reference is non-owning. In other words, if I return star new of something as a reference, don't do it. Because not only have you now sent something out so you know that it has to be a delete, but there is no pointer out there that gives you the hint that you delete it. So a lot of the guidelines have to do with resource management, and the analysis software, actually the existing stuff that's shipping from Microsoft, is actually catching this, and I believe that other efforts are in place to catch things that has been specified in the core guidelines. Lately I have found that people have learned to express things directly in code a little bit too well. I see a lot of code that has no comments in it, because in the old days people wrote comments, pages and pages of comments, and they tended to be out of date and unreadable and imprecise. And then in a lot of places people said, no, comments are bad, we won't have them. And now I can't see what it is you're trying to do. I can see what you do, but I can't see if you meant it. And so basically the rules in the core guidelines example here, you express things directly in code. But there's things you can't express directly in code, and that is, why is it there? What is it what you're trying to do? So basically intent should be in the comments, and comments should be crisp, not hidden in sort of somebody trying to write War and Peace because they really wanted to be an English major. So things like that matters. And the old rule is if the comments and the code disagrees, both are probably wrong. And I actually applied that rule when I wrote the ARM, the document that started the standardization. I tried carefully to say everything twice, because then if I screwed up, there was a high probability I would be caught. These days, when people write specifications, they try very hard to say things once only, which is sort of fine, except that I can't see if they meant it. So if I read a statement in the standard, I don't actually know if that was what they meant to say, and I didn't quite understand it, or they didn't quite understand it, and I can't see it. So comments are important. So there's a fair amount of philosophy rules there. I have chosen to illustrate this with Archimedes, arguably the world's greatest architect. Sort of a philosophical view of things, a framework for your design, a set of overall rules is important. I'm not going to go into the details. I encourage you to go on GitHub, find the core guidelines, look through it. If there's some you like, or if some that don't like, send me an email or put in an issue or something so that we can improve these things. And basically, my aim is very simple. We can write, type, and resource safe C++. My first step is to make sure that I can do that reliably. That requires tool enforcement. The tool enforcement is incomplete now, but we're improving. But basically, no leaks, no memory corruption, no garbage collector, no limitations of what you can say, no performance degradation. This is, after all, C++, and write in ISO C++. I'm not a fan of proprietary extensions. So this is happening, and I think this is part of what it takes to teach. You have to figure out what it is you teach. You have to articulate why that is a good thing to do. And so teach for the future, you have to live in it. And the world shouldn't continue to accept sort of unsafe bloatware, and probably won't. And if we don't improve, somebody else will try and improve it for us, and we may very well not like what they come up with. So the proof of the pudding is in the good code, and there's a lot of practical stuff that has to be done to do this. Correct, maintainable, appropriately efficient is sort of my version of Vitruvius there. And we need to work on curriculum development if we are in the education business, and learners should build on portfolio, not just go for the grades. It's really, really hard to get current day students to learn as opposed to SWOT for the exams. Yes, that is. So now I come to the question area, and I'd like to point out I know very well that I have not said everything that should be said about these subjects. There are several other things to do with learning, training, teaching at this conference. You can go there. There's in particular a panel tomorrow evening where we are talking about C++ in academia. I'm a panelist, and so are a couple of other people. Okay, questions? We have microphones up here, right? Is there one on each side? Please use them, because I really can't hear if you don't. This is an awfully large room. There's so many more people than there was last year, and last year it was large already. So, yeah.
Hey, so the core guidelines, you've mentioned them, you've mentioned about teaching with them. They're quite large as they are, and that can be quite overwhelming for students to take a look at the core guidelines directly. How would you recommend approaching teaching the core guidelines and getting students to take a look at them? First,
I suggest that you read the introduction to the core guidelines that says what's there and why, to have the rationale. And then look at the philosophy sections, pick a couple of those, and then pick some relevant rules to focus on. As ever, you can't teach everything. The core guidelines were not attempting to be everything for everybody or to be minimal or orthogonal. That is, if you look at a certain section, that section is reasonably complete for a lot of people, and you may have repetition over on the other area. I don't mind that. If we are inconsistent, which we have been repeatedly, people find it and tell us, and we clean it up. Now, your colleagues, the students, will not need everything, so you have to make up your mind where to focus them. But begin with the philosophy, the general understanding of what we're trying to do, and then focus on something important. I don't think we're going to be really successful on a sort of a worldwide scale till we have better static analysis. I want to eliminate dangling pointers, full stop. I want guarantees that there's no dangling pointers in my code. After that, I can give you code safety and resource safety and things like that. But first, we have to eliminate the dangling pointers. That is a thing that takes static analysis, some coding discipline, which is in the rules, and some support libraries, including the parts of the standard library. And so, as it is now, we're still working up to that. But I want to scale this out to sort of 4 million programmers, and you don't do that without tools. You cannot talk your way into that scale. And currently I am doing more talking than deployment of tools. And that's unfortunate, but we'll get there eventually. The team at Microsoft that started out with this is, in a way, I think, I see Peter sitting down there in the front. Are your guys getting onto this? Yeah. See, other places are catching up too. I know some projects in China. I hope to see more in Clang Tidy. So we need tools to get there. And that will answer your question. People will not have to find the rule. The rule will find you. You give it the code, and it'll drop you on the rule, which has what is the rule, why is the rule there, what is an example of why the rule is there, and what do you do instead. That's where I want to go.
Thank you.
Should take one from there.
All right. So in general, some people would like to see in the standard some solution that work better for beginners. I'm thinking, for example, of generating random numbers. The solution we have in the standard library is great for me, an expert who can use them. But some people would like just a simple function. And usually we can't get those in the standard because there are different, needs by different people. So do you think C++ could use just a separate library that just adds some of these simple solutions for beginners, new string formatting, new
Do you know the concept of a violent agreement? This is when people keep arguing long after they agreed because they have to be so keen on saying that they agree. That's what I feel like now. I have been arguing for that for ages. I mean, the random is the random number library that every random number library wants to be when it grows up. And as a result, people use rand, and they get really bad results. And I think, the standard committee would do well to remember that they should make simple things simple, and they should put things in the standard that help this. A very simple random number function, something that can compete with rand, should be there, and so should, say, split, not because I like split most, but that when people come in from Java and C#, that's what they try for. They don't understand how to get it out of I/O streams. So things like that should be there. Similarly, for the beginners, I think we should have a guaranteed range checked set of containers, and I want that portable across all implementations, by the way. And you can take the training wheels off later. That has something to do with the idea of a package for beginners. When I was teaching undergrads, there's always one smart, elegant guy. It's always a guy. The women are smarter. Who wants to tell me and all of his friends in the class that really you don't use vector and string, you have to use pointers and malloc because it's more efficient. No, you shouldn't do that, and I would like to stop them from doing it, because then they spent their nights debugging stuff that they should have finished at dinner time. And usually I find this guy and I ask, why are you doing this? Efficiency. What optimizer options do you use? And usually the answer is optimizer. Okay, so which system are you using? Let's pick Clang. Which optimizer option do you use? I don't know. Do you use -02? What's -02? You are talking about efficiency and you haven't switched on the optimizer. Okay, so things like that is important, but I think we need a package for beginners, and it should definitely have the random numbers. I love random numbers for getting semi-realistic programs to run. There are a few little things in the GSL, the Guideline Support Library, that helps, but we hope to put that out of business by putting it into the standard, and that really is help for professionals as opposed to beginners. it would be nice if there was a beginner's library. And by the way, don't try and teach people today in high schools and early university without a little bit of graphics. They don't believe it's real computers. And it's hard to do because we don't have that package that just install this one, use this one. Random is a relatively easy example. I have a support library for my course. It has a random like that in it.
All right, thank you.
Yeah, about those packages, the bundles that you propose for beginners and intermediate and advanced, those libraries, I mean, they would get some extra standing as compared to other libraries. So is that, do you think that should be part of the standard, or should it be just libraries that are developed by the community and then elevated into the status of being part of a bundle, or how do you see that working?
The standard is and should be tiny compared with what's available in the greater world. So the way I imagine this system would be not the standard, but packages that educators or early developers, junior developers could use, and I would hope that it would come out of the community. And there are two things we need for that to do. We need better package and build systems. I know they're being worked on. I'm putting this in to encourage people to do more, not to criticize unconstructively. And we need modules so that I can just grab things and be sure they don't interfere with each other. I mean, you have some things and you include a file, and some idiots 10, 15 years ago defined a macro called min, and your code stopped working. And you, of course, would say, oh God, not again. A novice would be completely flawed. It comes out of nowhere. So I think package build systems, packages with related build systems, and modules are very essential for doing good teaching. They're essential for other things too. I don't see the standards committee doing it. The standards committee is a little bit too expert friendly in my opinion. You've heard me going on about making simple things simple. It's not the main focus of most people in the committee, and so community.
So you would see there being options for like different bundles for, say, graphics libraries or
something like that, yes.
All right, thank you.
But this is sort of, I'm waving my hands here. It is not a precise specification.
I had a very specific sort of situation not too long ago. I was working on a project with my daughter who has a very good aptitude for coding, but doesn't know C++. We were working on a thermostat project, so it has little graphics, a little robotics, kind of stuff to keep you interested, good stuff. I did what I thought was a good thing. I created a little abstraction for getting the temperature out of the temperature sensor, and I gave her a task to do with this. And I found that the amount of C++ I needed to teach her was beyond what and she's a college student, so it's not like she has no attention span, but it was beyond her attention span. And I was wondering what your thoughts are on that in terms of sort of getting started with something that's going to do something concrete. It's going to click some relays, it's going to show something on a display, but it seems like even the simplest thing requires the first entire semester of C++ to do.
That is a major part of the problem. And if you tell them to download the library that makes it easier to use and install it, that's beyond them too. So that's actually the deeper reason I was going on about packaging and modules. We badly need modules, and we badly need modules that can do the simple, clean things simply.
Right, but I'd even gone beyond that because we didn't need the modules. I already had the abstraction there.
Wait. I'm just getting warmed up here. Then we need libraries that are actually aimed at people who are not CS majors. And a lot of our libraries are aimed at CS majors, written by and for CS majors. That's very, very limiting. You need things that goes beyond that. I know there's a session at this conference on Friday that I would have gone to if I had been in town, but I have to be somewhere else. I think that addresses something. The people that are starting with young kids are actually getting some of the ideas that will apply to novices of all ages. And as I point out, I'm a novice in many fields most of the time, so I'm not being patronizing here. For some people, something like Raspberry Pi is just wonderful. And that's an adult thing too, not just for kids. So we need to do more and better, but I can't be concrete on your example. You're touching in the middle of a very hard problem.
Yeah, thanks.
Hey there, I'm going to switch gears a little bit from what we've been talking about, although I think you just touched on it. At the very beginning of your talk, you talked about how your aim is mostly towards students who are going to be professional software engineers in some sense, do some software work professionally. But how do you feel about programming also just as a way to teach rigorous critical thinking to anybody, like how we teach math to everyone, not just people who are going to be technical, and how would that change your aims as a teacher?
I think that's important. Traditionally in our culture we've used mathematics for that, and people aren't getting enough mathematics in my opinion. You can do programming as a far more concrete and instant feedback form of learning critical thinking, learning precise thinking. Code is very good at hitting back where you are thinking in a woolly manner. And for that, I think the most important thing is that you don't make it too easy, and in particular, you don't make it fuzzy. There are a lot of work done so that if you say something, it'll do something. And it's not too fuzzy about what it is. If what you're wanting to teach is precise scientific thinking, precise things. The reason I focused more on the software developers was that's what I know best. I'm very reluctant to say precise things about things I haven't actually tried myself. And so I mentioned it as an important area, but I think it's an important area that takes some serious work by somebody who isn't me.
Thank you.
Yes, two comments. One is on the guidelines themselves. I think that's probably one of the best things I've seen toward the language in the last 2 decades. A problem, though, is that I was trying to encourage a section of my company to use it, and they happen to be in Germany, and they didn't really understand the preamble. They didn't get the joke, actually, about it being incomplete and such.
Oh, that yes. One, yes. Yeah. Yes, we're okay. I mean,
no.
There's a joke about Germans lurking here, but yes, maybe it's time to take that one away. It's the same that we're using in some of the drafts at. In the standard documents and in the proposals. Yeah. Yes, you're right. That may have outlived its purpose, and jokes don't travel culturally. I know that, and I think I slipped up there. Thanks.
And one of the difficulties is that I work in a highly regulated industry, in the medical devices industry, and getting GSL to be used as the library is difficult because there doesn't seem to be any stated direction as to when it's going to be proposed or entered, and so having that guidance there as to at what level it's going to be proposed into the main standard library or what track it's going to be on would be nice, especially since some of our code is vintage.
Yeah. There's always the inertia of old code and old think, and that we have to fight in every industry. I work in a highly regulated industry. Well, people don't die if we screw up, but they may jump out of windows with the same effect when they get ruined. So we have some of those problems, and we have gotten permission from our regulators to use things like that. So it can be done. But I hope I said it somewhere in the guideline preamble that we need specific guidelines for specific areas, and we just haven't gotten there yet. It is still the core guidelines, but if you look forward 10 years' time, I would expect there would be the medical appendix and the financial appendix that has specific rules, supports and restrictions suitable for an industry. I know most of us has to worry a lot about the next release and the next quarter. I try reasonably hard to think about sort of 5 years, 10 years out in the future, because it is going to come incrementally from what we are doing today. The core guidelines is good, and it'll be much better in the future. But boy, do I wish it was moving faster and we had better support and better enforcement and things like that. I guess I'm somewhat impatient with a lot of things.
The one from Microsoft works for most things, but it's also nice that there's a single header GSL Lite one that actually goes back to more ancient code. So
it's a lot of these things work together. I can't wait till I can say without caveats, use concepts for all of your template arguments. If you want a fully generic piece of template argument, say so, like define the concept takes everything, and use modules to make sure that you don't get infestation from other people's macros and type diffs. And that works together with the views in the core guidelines. There are things that we can do much better with what, in my opinion, should have been 17, but not everything can be 17, so let's go for 20, and the guidelines will be better for it. And it's from my perspective, it's the same kind of thinking for getting us to the future.
You was talking about how using libraries is important and how writing your own linked list is probably not the best idea, and I can't agree more. But say like 10 years ago, when I was writing my first multi-thread application, I invented my own atomic. So the bad news is it was actually used in production, but the good news is that I learned a lot while doing this. And you might have heard they say that you're not a real programmer if you didn't implement your own string class. So the question is, if we have a generation of software developers who didn't implement most of basic constructs, but they already learned to use ready abstractions and libraries, should we miss something, or maybe this is the right way to go?
If we don't teach people how to do lower level software, we get a generation of programmers that only know how to use a library, and that's wrong. When I teach people, when I teach freshmen, I teach them how to implement vector, because they need to know about pointers and free store, and they need to screw up so that they see it's good to encapsulate it and those problems don't happen anymore. When I teach later on, I very often have people design and implement a string so that they can see how it's done, and so I can show them how they could have done it better. So yes, we need to get down to at least the C++ memory model at some point. Otherwise, we teach people magic. So you have to get down there somewhere. I thoroughly agree with that. On the other hand, I don't think everybody needs to write a log-free code. If you are a computer science major and if you're specializing in sort of engineering uses, yes, you must do that, but not everybody. But yes, you have to reach some level of abstraction that is good for what you're doing. And for computer scientists, I really think they should know how a vector is implemented in some extent and how string is implemented. They should know how to do the short string optimization, for instance, because then they understand.
Yeah, that's great when you teach your students, right? And imagine that you have a junior, for example, in your company, and you see that he's trying to implement some basic stuff, and you tell him, don't do this, it's already done. Yeah, that's great. But perhaps he was trying to implement it because he don't actually get how it works, and he don't want to be using magic. So it's from a practical point of view, I don't want him to write it. But from the educational point of view, it would be convenient to do this.
In a concrete way, look at chapters 17 and 18 of the Swan book. I have done that for 10 years. That's the vector implementation. It's a way of trying to address your concern for first-year students. People who had never seen a line of code before they started chapter 1. So I don't drift into just the stratosphere. It's not what I'm recommending.
So you were talking about Raspberry Pi. I ended up doing a summer project on one and ended up doing it in Python, which was nasty. But so with your talk of modules, for the Raspberry Pi, there's a lot of stuff with setting up I2C connections for connecting different components, setting up the different PWMs on the pins. Mm-hmm. So would you have like a module for Raspberry Pi that's specific for the Pi, or
I think when you get to real hardware, you need dedicated facilities to make that hardware reasonable to use, yes. And so I would expect once we get modules in the language, C++20, that was not ready for 17, I would hope that Raspberry Pi would have a basic Raspberry Pi support module or something like that.
That'd be great, because it's another thing, like you said, where it's good to have interfaces and stuff, which Python has a very simple Windows 98-ish one in.
I know. Hence the talk about photography here. I wish I could have done that talk for C++, but I can't.
Thank you.
Later.
Hello. So I volunteer teaching high school kids, and there's always the question whether, I'll give an example. For example, when I teach operator overloading or stuff like that, and I'm teaching them like copy constructors and operator equals, there will always be the student that will ask about move semantics and stuff like that, because they are sitting with their laptops and they'll Google it. So how would you go about finding the golden ratio between what's essential to teach them modern stuff, but also not overwhelming?
I mean, that's a very, very hard question. I don't really know. I can point to this one book. When I had the concrete problem, not for high school students, but for freshmen, that was my solution. And I think some of that is pretty fundamental. If you're dealing with people who want to be software developers, you have to go through the usual stuff. You have to show them what a loop is, what a function is, how to build a class, how to use a class. And you will eventually, I think it's chapter 10, get to move semantics and such. For high school students, you can't quite do that. One of the problems is that people always read ahead and they want to try something else. That was what I said, these people that decided that pointers and malloc were cool, and they wanted to be the cool kids and corrupting the others. That's always a problem. And I think a good teacher will find a way of handling the students, knowing the students and such. What you can do in preparation is to have a curriculum that provides abstractions that's relevant to what they're doing, so that you can say, yeah, you can do that, but if you use this one for now, you'll get to bed at a reasonable time. I mean, do you really want to stay up past midnight debugging all the time? And sometimes when this happened to me, somebody heard of move semantics just when I'm trying to teach them how to write a string out to output. I say, well, we'll get to it. They don't like that answer, but sometimes it's the only answer. Otherwise, you end up doing bottom-up. And with bottom-up, you never reach where you want to get there. All the time is spent inventing macros for hiding malloc so that you can catch errors and things like that. You don't want to go there. So try for suitable abstractions for your people and try and deal with what's fallen out, what then happens. We are over time, so maybe we should stop. I will be around today or tomorrow, so try and catch me. There are people streaming out in the back, which is fair since we're 10 minutes over. So I'd like to cut it now. Sorry for you standing up there. Thank you.
Bash Films can shoot your event with multiple cameras, link to presentation slides, add titles, and edit your event live for a full broadcast experience.
How is this even working? So this is actually a more interesting program to look at in a lot of ways. So let's profile it. Give it a little bit of time to do a profile for us. Let's see exactly what it is that's making this faster or slower based on the different inputs. I mean, you can really gain a lot of insight by actually looking at the profile like this.
I worked at Sesame Street. I got brought on to be a writer's assistant on a show called Sesame Street English, which was to teach English to kids in China and Japan. It seems very simple, the shows that they put together, but it's actually really hard to design a show that is not only for young kids, but also the parents.
Confession like this is therapeutic. I hope you all get something out of this, but if you don't, the therapy will have been good for me, so thank you. 7 years ago, I wasn't working at Google. It was for my previous employer, which was a large multinational investment bank. I had what was up to that point the worst day of my career.
And then came the anger at ourselves because we knew we were responsible for America's first space disaster. We wrote 2 more words into our vocabulary as mission controllers: tough and competent. Tough meaning we will never again shirk from our responsibilities because we are forever accountable for what we do. Competent will never again take anything for granted. We will never stop learning. From now on, the teams in mission control will be perfect because as a team, we must never fail.
One other thing. We're all in a very fortunate position. We've been very lucky in our lives and so forth. And I think as part of the mission, it's also good sometimes to take that fortune and give back. To make sure that we take this platform and use it towards worthy causes. That's good karma. That's good stuff in the universe.
We understand that your event will have needs that are specific to your organization. Please email or call us directly to discuss your particular event. We look forward to discussing your goals and helping make your event a success.